All right, so we have a second question of standard nature as well. When a particular metal is irradiated, okay, is irradiated simply means when light is shown on a particular metal. That's what it means, okay? Of a certain wavelength, 10 raised to the power minus 7 meters, a potential difference of 8 volts is required to completely stop the photon electrons. Calculate the work function from the metal. Okay? Calculate the work function of the metal. So, can we just illustrate something here? First of all, let's bring out what we have. Let's just bring out something. What we have. Here we have a particular metal is irradiated. That means a particular metal is shown with a light of frequency of wavelength, excuse me, okay, is irradiated means this metal is shown, okay, there is this light shown on this metal whose wavelength is given as 10 raised to the power minus 7 meters. That's what it means. But we need a potential difference of 8 volts to completely stop the photoelectrons from being emitted anymore. So that's what this means. Let's just do an illustration here. Let's see PD, potential difference PD is given as 8.0 volts. That's the first thing. Okay, wavelength is given as 10 raised to the power minus 7 meters. All right. And what next? We have to calculate the work function. That's it. We need to calculate the work function. And for us to do that, we first of all need to understand what actually happens here. This is the surface of a metal. Light is shown on this metal. Electrons are ejected. Electrons are ejected. Can you see? That's what it means. Light of a particular frequency is shown on this metal. At this point, this is the energy HF, okay? And this is the kinetic energy of the emitted electron, which is 1/2 mv squared. Something happens here. That's work function. So amount of work is done there for the electrons to be emitted. Okay? So this is E, okay? Energy. This is work function. This is kinetic energy. So there is a connection here. E is equal to work function, right? Plus kinetic energy of the emitted electrons, mv squared. But there is something that has been worked out for us. It's been worked out for us to make use of. So the kinetic energy of the electron is always, if you know that the energy of the electron is given as 1.6 times 10 raised to the power minus 19, okay? Electron volt, this is coulombs, right? For us to convert this to electron volts, we already have potential difference given as 8 volts. So what we need to do is to multiply this. So if we do this, it becomes electron volts, which is now equivalent to kinetic energy of the electrons, is given as 1.6 times 10 raised to the power minus 19 times 8. All right? That's what it means. And eventually we are going to have 1 point. If we now 1.6 times 10 raised to the power minus 19 times 8, okay? We now give 1, it is now 1.28 times 10 raised to the power minus 18 joules. So we have now succeeded in calculating the kinetic energy of the emitted electrons, right? So that's it. That's the first thing. Then the next thing for us to calculate the energy of the photon, the light incident on the surface of the metal that causes the emission of these electrons. That's what it means. So for us to do that, we need to calculate this. Since we are given wavelength is given, so we need to calculate E, the energy of the photon. The energy of the photon, right? So we do that by saying E is equal to Planck's constant hf which is also HC all over wavelengths. So we can work with this. Yes, we can work with that. And we do proper substitution. We have for Planck's constant, we have 6.6 times 10 raised to the power minus 34, right? Good. All right, bracket close. For speed of light is 3 times 10 raised to the power 8, bracket close again, all over wavelength. The wavelength given is just 10 raised to the power minus 7 meters. Very simple. We just write 10 raised to the power minus 7 meters. That's all. Okay? So finally, what do we have? The energy of the photon emitted, photon incident on the metal plate. Okay? On the surface of the metal. Yes, this. The energy is what we are looking for now. Okay? So we now have that as 1. By the time we evaluate this, take note of the powers and evaluate appropriately. Okay? We have something 1.98 times 10 raised to the power minus 8. Okay? So that is it. So we have this, and energy is measured in joules. Now we have found the energy of the photon. We've also found the kinetic energy of the emitted electrons to be this. We do simple. Look at this. We're looking for work function. W naught. Work function. Look at it here. W naught. So we make work function the subject. We transpose here and make this work function the subject. And it becomes work function W naught is equal to energy of the incident photon minus the kinetic energy of the emitted electrons. All right? Good. That's it. So let's see what happens next. Since we have this, I think this is clear. I hope it's clear. We have work function can be calculated. Work function is this. Energy is my chalk. The photon energy, right? E minus the kinetic energy of the electron, half mv squared. So let's go. Work function now is equal to, for energy of the photon, which is 1.98, we have 1.98 times 10 raised to the power minus 8, so to say, up and right. Okay, and then minus this, minus, we subtract that, okay, minus the what? Kinetic energy of the emitted electrons. Kinetic energy of the emitted electrons given as 1.28 times 10 raised to the power minus 18. So let's see. I hope we're making progress. That's it. That is it. Okay. So what next? Very simple. If we do that, we cannot say that work function is equal to 7.0 times 10 raised to the power times 10 raised to my chalk times 10 raised to the power minus 19. Minus 19 joules. Okay. All right. So let's see. Of course, by the time we evaluate properly, we are going to see all that play out. Okay. So that is what it is. If we understand this, that means we have really solved this problem completely. So the work function, look at the question. A potential difference of 8 volts is required to completely stop the photoelectrons. So we're looking for a way to stop the emission of these electrons from continuing. Yes. So what do we need to do? Calculate the work function. So we have just calculated the work function. 7.0 times 10 raised to the power minus 19 joules. Yes, work function is measured in joules, okay? All right, so I think that is what it should be, and that's what we expected to do at this point in time, okay? All right, so check the steps, and if you think the steps are not clear, of course, you know what to do. All right, see you in my next class.